Section 1.4 covered the segment addition postulate. So we're going to look at the worksheet on it now. So numbers 1 and 3. So for this, you're going to have a companion sheet. You're going to have a bunch of little bitty squares you can cut out and put these in. I just went ahead and wrote in what it is you're looking for. So for each of these three columns, you're going to put first a diagram of what is being described right here. The equation that you're going to use, that you're going to set up from this diagram, and then you are going to go through and you're going to solve that equation for the value of x. So let's look at this first one. So the first one tells me point B is between A and C. And then I'm told AC, so that's a segment in this picture, in this diagram. AC has a length of 3x plus 3. AB has a length of negative 1 plus 2x. And BC has a length of 11. And we are asked to find x. So we're setting up this problem. So first we see point B is between A and C. So I'm going to start by drawing a segment right here. So if B is between A and C, that means that I need to have A and C on the ends, and I need to have B somewhere in the middle. It doesn't necessarily have to be directly in the middle. It can be anywhere on this line. I think just out of habit, I'll just put point B in the middle. So we are told that the length AC has a length of 3x plus 3. So AC is going to be represented by the whole thing. So the whole thing right here has a length of 3x plus 3. AB, so from point A to point B, has a length of negative 1 plus 2x. So that's what I wrote down right here. And BC has a length of 11. So from B to C has a length of 11. So keep in mind the segment addition postulate told us that if I have one big segment and I cut it into two smaller segments, then the length of the two smaller segments, when I add them together, will equal the length of the whole. So that's how I set up my equation up here. So I've got one little piece is negative 1 plus 2x. I put it right there. My other little piece, 11, I put it right there. So I add those together, and I set them equal to 3x plus 3. And that's going to be my equation. So now from here, I move over here, and I start solving for x. So I take the negative 1 and the 11, add them together, and get plus 10. So now I've got 2x plus 10 is equal to 3x plus 3. I take 3x, move it over here. So 2x minus 3x gives me negative x. Take the 10, move it over here. So 3 minus 10 gives me negative 7. So negative x equals negative 7. So x equals 7. Okay, then we come down here and we look at number 3. So number 3 tells me DE bisects AB at C. If AC has a length of 8x minus 23 and CB has a length of 3x plus 22. So we start. DE bisects AB. Okay, so it didn't matter which one you wrote up and down, which one you wrote left and right. Okay, a couple different ways you could have drawn this picture. This is how I decided to draw it. So if I'm told a DE, so this line right here is bisecting AB, this line right here. Remember, if something is bisecting something else, that means that it's cutting it in half. So DE is cutting AB in half at this point C. So I put the two tick marks right here to indicate that AC and CB are equal to one another. So I'm also told a value for AC and CB, so I put them there. So AC is 8x minus 23, so I labeled it right there. CB is 3x plus 22, so I labeled it there. So now for my equation, I know that these two are equal to each other, so my equation is going to be setting them up equal to one another. So 8x minus 23 is equal to 3x plus 22. So now I want to go through and I want to solve for x. So I set it up over here, move 3x over here, and I get 8x minus 3x is 5x. Take my negative 23 and I'm going to add it over here. So 22 plus 23 will give me 45. So I've got 5x is equal to 45. And now lastly, I want to get x alone. So I'm going to divide both sides by 5, and I'll get x is equal to 9.